So to start off, just finding the derivative, that's straightforward. And k is a constant, so the derivative of that is 0. Then they tell us that the equation at x equals p is 7x minus 9. Well, that allows us to say, this is my equation of my tangent line. It has a slope of 7. And if that slope is 7, I can plug that into my derivative and solve for x. And I find out that x is equal to 2. So that means that p has to be equal to 2. So that helps us find the value of p. If we look at a picture of this, that's just showing that tangent line on that curve. Then for finding the value of k, you know that when x is 2 on your tangent line, that y has to equal 5. So now we know that that point where the tangent is on the curve is at the point 2, 5. And we can go back to our original equation, plug in 5 for our y value and 2 for our x value, and then can solve and find out that k is 3. So it's just all the same kind of ideas are happening in this question. They just happen in a different order. So you have to be able to think through the normal process on how you would find an equation of a tangent and the things that you would have, right? In the normal process of finding the equation of a tangent, you do the derivative. You would use your point to find the slope. So this time they gave us the slope, and we had to use that to find our x value. And then normally we had point and a slope to find the equation of a line. This time, since they gave us the equation of a line, we could use that to find the slope and the point. So it was a little bit of working backwards, finding things, the other things that normally you're given, now you had information to find them. So that is the last example from our tangent section. The next section is looking at normal lines. And all a normal line is a line that is perpendicular to the tangent line. So the only thing for finding the equation of a normal is you have to know how to find the slope of a perpendicular line. Now, in English, we'll say that the slope of a perpendicular line is a negative reciprocal. Okay, and in French, the reciprocal word is totally different because it's the inverse word for the reciprocal and reciprocal word for the inverse. So that's probably the most confusing thing coming from French to English, right? But you've done slopes of perpendicular lines. What do we do if we know that the slope, if we knew that the slope of our tangent was 2/3, then the slope, I'll put a little t here for tangent, then the slope of our normal line, you would flip your fraction and change the sign. So then the slope of our normal line would be -3/2. So all this is saying the slope of our normal line, multiply it by a negative, and it's just 1 over the slope of our tangent, which causes you to flip the fraction. In English, that word is reciprocal. Whenever you multiply the slope of your normal times the slope of your tangent together, you'll always get -1, which you can see with this example that we did. If I would take 2/3 and multiply it by -3/2, everything would cancel out and I'd just get -1. So the process of finding the equation of a normal line is almost identical to the process of finding the equation of a tangent line. We just have one extra step. We're going to find our derivative. Same thing that we did before. Once we have our derivative, we're going to plug in the x value to find out what the slope of that tangent line is at that particular point. So now that we know that a slope of our tangent is -8, you can write that as a fraction, -8/1, then the slope of our normal line will be the reciprocal of that. And again, finding an equation of a line, you need to have your point and your slope in order to do that. We've got our slope, we've got our point. You can either use y = mx plus b or the point slope form of the equation of the line. And then just rearrange it. Here I multiplied both sides by 8 to get rid of the fraction. Rearranged it and then divided by 8 in the end. And you get your equation of your normal line. So right here I've got the equation of the tangent line. The only difference is we're plugging in a different slope. And if we want to see what this looks like graphically, our original equation was a cubic function. In black there we have our tangent line, and then our normal line is at 90 degrees. So once you've done this one, if you want to try the next one, if you want to see if you got sort of the first things right so far, calculating your slope. So then once you've got that slope of the tangent is -3, then you can find that the slope of your normal would be 1/3. You have the point. Once you have your slope and your point, you can find your equation of your line, and it's 1/3 x plus 11/3. So finding the equation of a tangent at a point on this curve, and then it says we're going to use our graphing calculator to find the coordinates when that graph intersects the curve again. So to start off with, we can find our derivative, no problem. We can plug in -1 like we've done before and find out that the slope of our tangent is -2. And now that we have the slope, we have a slope and a point, so we can plug it into our point slope form and rearrange it, and we find out that the equation of the tangent line is y = -2x. Now if you go to your graphing calculator and you type in x³ minus 5x minus 2 into y1, and you type in y = -2x into y2, you're going to get this graph. And at the point -1, 2, that's where our tangent line is touching that curve. Can you see that it hits the graph at another point again? So what you need to do right now is put those graphs in and see if you can get 2, -4 as your other point. If we didn't have a graphing calculator, could you find this? How would you do that? Okay, so how do we put it back into the equation? If we want to find that 2, -4 algebraically, what do? Okay, so we have Our blue line is y equals x cubed minus 5x minus 2. Our tangent I'll do in red. That's y equals negative 2x. How do you find out where two lines intersect? You solve the systems of equations, right? So if we made them equal, if we substitute in, we could say instead of the y in the first equation, I'm going to write negative 2x. And I was playing around with this earlier just because that's math teachers do, right? We play with numbers. And this equation, I said, well, how do we solve this? You make one side equal to 0, and then it goes back to something that you learned last year. How do you solve this kind of equation? You don't? You have to factor it. How do you factor something like this? You have to use your factor theorem and your remainder theorem. Okay? Now, normally that could take a little bit of time, right? Normally that could take some time because you had to look at the last number and say, plug in 1, plug in negative 1, plug in 2, plug in negative 2. But I'll tell you that from this equation, since you already know that it goes through x at minus 1 comma 2, you already know that one solution is x equals minus 1, which means that x plus 1 is a factor. Do you remember synthetic division? So if we use synthetic division on this, we'd have 1, 0, negative 3, negative 2, and you'd have a negative 1 out in front, right? So you would bring down the 1, multiply, get negative 1, add negative 1, multiply, get 1, add, get negative 2, multiply, get 2. And sure enough, since we knew that was a factor, you get a zero's remainder. And now you could say that x cubed minus 3x minus 2, which is our equation that we had, can now be factored to be x plus 1 multiplied by x squared minus x minus 2. And that is easy to factor to x plus 1, x minus 2. And we get our second solution as x equals 2. Now, when I was playing around with this, I guessed that this might happen. I hoped that this might happen. And when it happened, it made me happy. But you notice that the x plus 1 happened twice. And if you think about if you were graphing this, do you remember graphing these last year where you said, well, I know that my one x-intercept is at 2 and my other x-intercept is at negative 1. This is an x cubed graph which has n behavior like a cubic that's going up from left to right. How does this graph go? Well, it would be coming from down here. What happens at negative 1? Bounces and then goes through. And what I found interesting about this is if we look at our original equation, even though it's off to the side, doesn't our graph bounce off a tangent kind of idea? So I was curious to see, would we get that factor twice? Does that always happen? I don't know. It seems like it would make sense that it would. But then we'd have to make up a whole bunch of examples to think about that some more. But I thought that was interesting. But that's not what this question asked for. This question asked, could you do it with your calculator? But sometimes you'll get similar things where you need to do them without your calculator as well. So I wasn't really going off on a tangent. Okay, that was bad. All right, find the equation of a tangent and normal lines to this one when x equals 3. So then once we have our derivative and we've calculated both the slope, so when we plug numbers into the derivative, that always finds slope. When we plug numbers into our original equation, that's going to find the y-coordinate when x is 3. And so we have our tangent slope is negative 1. Our point is 3, 6. and we can find our equation of our tangent line. If we want to find our equation of our normal line, the slope is going to be the negative reciprocal, so the slope is going to be 1. The point is going to stay the same, and we can find that equation as well. So if we were going through the normal process of solving this one, we would take the derivative, then once we have a derivative, plug in our point to find our tangent slope, and then do the reciprocal to find our normal slope. But we have a problem here because we don't have a point. Well, we have a point, but when we plug in things, when we do our derivative, it has a k in it. But we're given some extra information here. The fact that the normal is parallel to this line, does it make sense that they're telling us the slope of our normal line right there? And then if we know the slope of our normal line is negative 1/8, we would know that the slope of our tangent is 8. And if we know the slope of our tangent is 8, that means that f prime at 1 is equal to 8. And we can use that information to plug in 1 for x and 8 for the slope and solve for k. There's some homework listed at the bottom for practice.